In this episode, we will talk about recognizing and correcting for dirty data. As you will recall from the previous episode, the Apple Decay Experiment, there were some errors being observed. To look at that, we're going to use RStudio, our version 3.4.4, someone to lean on. We will use the libraries read ggplot2 and mgcv. In the Apple Decay Experiment, we loaded the following data, and we received 12 parsing failures in the red and blue spectrum. And as you can see, the row 487, 1536, and 2079, and several others have trailing characters that do not fit. So let's view this data and see what it looks like. If I look at those values, you'll see that in the red and blue it's NA, and in the green there is some questionable data here, as most of the green data is 100 and something. These are 3 and 17, 12 and 13, which suggests that there might be a little bit of a problem in the data. So what we will do is we will search for these image files right here and put them into another location. For the purpose of this exercise, I'll open up the desktop Apple, and in the measurements we can search out those items. There they are. So for the purpose of this exercise, what I've done is I've already found them and placed them in the YouTube channel Dirty Data, and here they are. These are the images that have failed. I modified Python script to go to the Home Family Documents YouTube Dirty Data folder, look for the JPEG file, and using this print out the RGB values of red, green, and blue and write it to a file, and the file is going to be called Apple Corrected. So let's run this now. It's done. So if I look at files and PyCharm projects, data gen, there's the apples corrected, and I could view the file. There it is. And I'm going to close this and open Apple 2 and view the file. Do a find. There it is. There's my problem. So the corrected value is this. So I'll go Apple 2. Paste. There you go. I've pasted it in. It looks good. I'll make some minor corrections here. There you go. Now I'll look for the other one. This one right here. Find. There it is. I'll take these values. And I will put them in here. Just like that. Just like that. And now, make this correction. Done. Now I gotta find the other one. This one right here. Same procedure. And we could see what the problem is. And do that. And we'll do the other one. I hope you're getting the point. Of course, I could have reran the whole entire script again, but it's a 2-hour run with all those images, and this is just a little bit faster. And we'll do this one. Almost done here. And one more. There we go. I'm going to save this one as Apple 3. There we go. It's good to change the file just in case you made a mistake. You have corrected file, and you could always look at where you made your mistake with the original file if something was to go astray. There you go. So if I look at here, I see my Apple 3. So from here we could see Apple 2, and if I continue down this path and apply the red, if we go down this path, we could apply the variables X, R, G, and B as follows. And if you recall the plots that we saw in the previous slide, which I will show you, we saw the blue looking relatively okay. The green had a lot of outliners. Hopefully we've corrected those by those errors. 1, 2, 3, 4, 5, 6. So it looks like those are the ones. And of course the red band. So let us take a look. I will now apply the Apple 3. And Apple 3 is here. If I go along the reds and that, there should be no errors. Oop, I do have one error here. I'll correct that. It's always good to look at your data again. We'll go to PyCharm, data gen, Apple 3, view file, go view Apple 3, do the red thing. This is the one that was an error. Go here, find this, there it is, and I will make that correction now.
Don't you want some light, Jen?
Done.
Don't you want some light?
No.
So save the file, apple3.csv. I'm going to reload it. And let's see if we got any of those errors. Nope, everything looks good. Everything is correct. So, as we could see from the previous, we got this green thing, and it's kind of messed up. Let's see if we could correct it. The blue band, the green band's a lot better. No errors whatsoever. No outliners. Looks good. Red looks good. So with those, we should be able to plot these and see where the errors are. Let it run its course. There you go. This is the blue line. This is the green line. And as you can see, there's no errors being reported. And here's the red line, nice and clean. So, red, green, blue. No outliners being observed. Compared to the previous, much cleaner, especially in the green band. Good representation of data. And that's it. That's how you correct dirty data. Thank you for watching and have a great day.